Hey guys, this week we're going to be looking at solving equations with square roots. And to start this off, think about the activity that you did 2 weeks ago where you looked at the video of the stopping distance of a Porsche at different speeds and you plotted the data as a table into Desmos, and Desmos gave you a graph that looked like this. So you had the speed at 30, 40, 50, 60, and 70 miles per hour. So the speed is on the y-axis and the stopping distance is on the x-axis, and you can see the graph represents the relationship between the two. The graph, the blue line, is actually the best fit line between all the points. And from Desmos, we also got an equation of this line. So the equation that best models the speed and the stopping distance of a vehicle is something like this. It was speed, and of course that's the y-axis, is equal to, and we got these numbers from Desmos, it was 3.6 square root of 1.1 times x minus 30 and then plus 30. So last week you guys learned about transformations, and of course this is a stretch and this is a shift, and this is a shift to the right, and this is a shift up, and you can see the graph resembles that. So remember, x here for this application represents the stopping distance as well. So let's look at an application of this. Let's look at this problem with a Formula One race car, and doing a quick Google search, I found out that the Formula One race cars, they hit about 233 miles an hour when they drive. And so I thought, based on our model, what would be its stopping distance if it slammed on its brakes? And of course we have to assume that the tires aren't going to melt when it's going that fast, because that's likely what's going to happen unless they're made from some kind of crazy material. But anyways, if we know that its speed is 233 miles an hour, let's plug that in for the y. And on the other side, we have 3.6 square root of 1.1 times x, and x is what we're going to be solving for. We want to find out what the stopping distance is going to be. Minus 30, it was actually 30.5. 30.5, I rounded some of these numbers off to the 10th, plus 30. And so to solve this, like you would solve any equation, the constant has to get eliminated first. So we can subtract 30 from both sides. So this gives us 203 equal to 3.6 square root 1.1x minus 30.5. So I do a step and I copy everything down, do a step, copy everything down. What do you think has to get done next? Well, before we can do anything, before we can touch anything inside the square root, we have to get rid of the stuff on the outside. So you can't, remember earlier in the year we said we can't touch this. So we have to get rid of the stuff on the outside. In this case, it means dividing by the 3.6 on both sides. So it cancels out on the right. And again, I'm rounding these numbers out. You get 56.4, I think it's 3.3 something, but 56.4 is good enough for our purposes. And then on the right side, you have 1.1x minus 30.5 left. Now think in your head what's going to be the next step here. Again, before we can do anything to the numbers on inside, the square root is a little bit bothersome. So the best thing to do is to just square it away, because the square of a square root just leaves you with the stuff on the inside. But since you squared it, you have to square the other side as well. And then putting this in a calculator and doing some rounding, 56.4 squared is going to be 3179.7. And then since we squared the square root, now we're just left with the numbers inside the square root, which is convenient because now it's just a two-step equation. So we're going to add and divide. So add 30 0.5, that cancels out, plus 30.5 leaves us with 3210.2 on the left side, and all we have left on the right side is 1.1x. And then one more step, if we divide by 1.1, we're going to have the x by itself, and that's of course the answer that represents the stopping distance. So if you divide 3210.2 by 1.1, you end up with 2,918 feet, rounded to the nearest number. So that means that at 233 miles per hour, it takes 2,918 feet for the Formula One car to stop. That's a long ways. As comparison, 2,918 feet is a little over half a mile, or 2 Eiffel Towers worth of stopping distance. Alright, so for this other problem, I'm not going to solve it for you, but I'll kind of walk you through the setup of it. I started thinking about planes and their takeoff speeds, and this is a Boeing 747, a very big plane. And so during takeoff, you have something called a V1 speed. And that's the speed that one of the pilots calls out. And what that means is, in order for the plane to take off into the air, it has to reach a certain speed. And V1 is the highest speed that takeoff can be aborted. What that means is if you're going faster than this V1 speed and you slam on your brakes, the plane cannot safely stop. So it's going to either end up crashing or catching fire, or the tires are going to melt. So that's why it's important to know this V1 speed. For a Boeing 747, it depends on how heavy it is and how much fuel it has, but let's say it's fully loaded. The V1 speed, after the speed it can't stop its takeoff, is 183 miles an hour. So if it does have to stop at this speed, the question is, what's going to be its stopping distance on the runway? So that's one of the problems you'll be looking at for next week. Thanks, and hope you enjoy it.